This is lesson 8.4, an introduction to logarithms. Our learning target and goal for this lesson is to be able to evaluate logarithmic functions. In order to evaluate a logarithmic function, we need to be able to go back and forth between logarithmics and exponentials. And the way that we do that, if we start with an exponential function, what a logarithm allows us to do is to solve for that little variable x. We don't know how to do that without a logarithm. And so in order to change it from an exponential form to logarithmic form, what we do is we start with the x, the exponent, and we say x equals log, and then the base of the exponential, the b value, will also be the base of the logarithm. So we say log base b of y, whatever it is that's equal to our exponential function. So for example, number 1, we would say x equals log, and then the base becomes the base of the logarithm, log base 2 of 9. Number 2 would read x equals log base 5 of 67. And number 3 would read p equals log base m of n. That's how we would change from an exponential form into a logarithmic form. In order to change from a logarithmic form into an exponential form, we need to remember that we started with the exponent. So this number here, x equals, that becomes the exponent in the exponential function. The base of the log is also the base of the exponent. And so number 1, we would actually start with the base. We would say 2, and then the 5 is the exponent, 2 to the 5th power equals 32. And it should make a true statement if we have all numbers. And if we draw little arrows, we end up drawing a little circle around that equal sign. So number 2, we would start with that base of 10. We'd say 10 to the 1 equals 10. Again, a true statement. Number 3, start with the 5. 5 to the 0 equals 1. And number 4, 2 to the negative 2 equals 1/4. And if we remember that negative exponents don't make negative numbers, they just flip over and turn it into a fraction. That's what a negative exponent will do. Some special bases for logarithms include 2 that are found on our calculator. 2 very common bases would be log base 10 and log base e. If we have log base 10, what happens is we don't write the base. So when you see just a log, you should assume that there's a little hidden base 10 in there. The other special base is called your natural logarithm. And the natural logarithm we actually write as ln, and ln is the same as log base e. So for example, if I need to rewrite some of my special bases into exponential form, log base 3, if there's no base, I'm going to pretend there's a 10 there, there's that hidden invisible 10, and I would write this as 10 to the x equals 3. Likewise, over here, natural log, there's a little hidden base of e, and so I would write this as e to the y equals 5. If I need to go into exponential form, I would rewrite 10 squared as 2 equals log, and since it's going to be base 10, I'm not going to write it, just log 100. Same thing for e to the x. I'm not going to write the base e. I'll say x equals, start with that exponent, log base e, I'm just going to write ln y, because this is the same as log base e. Knowing how to evaluate and knowing how to go back and forth between exponential and logarithmic forms helps us to evaluate logarithms without a calculator. So, for example, number 1, all this is saying is 2 to what power, put a little equal sign and a question mark, 2 to what power equals 16? And if we think about it long enough, we'll come up with 4 as the answer. Number 2 says 4 to what power equals 1/4. And if we think about it and remember how negative exponents work, eventually we'll think about this and come up with -1 for number 2. Number 3 asks 5, the base, to what power equals 5? And this one hopefully is nice and easy. It should be 1. Number 4, there is no base. So this is saying 10 to what power equals 100. There's a little extra little typo there. 10 to what power equals 100, and we can think about it and come up with 2. The next one, a little typo again. 4 to what power equals 16? Well, it's got to be 2. And number 6, natural log is a base e. So this is saying e to what power equals e to the 3x. Looks a little funny, but in order to make it a true statement, this question mark here has got to be the same as 3x. So that has to be our answer. We've simplified that expression. And lastly, my last 2 examples here says 3 to what power equals 3 to the x? Well, that question mark has to be x. Number 8 is a bit of a tricky question because it says, what can I raise this base of 10, remember that hidden invisible base, 10 to what power gives me -100? Well, in this case, there's nothing that's going to work. This actually is one of those cases where there's no solution. We can't evaluate this situation because no exponent will ever make 10 into a -100. And this brings us to a couple of properties for logarithms. The first rule or property is that you cannot take the log of a negative value, and you'll have to excuse this typo, negative. You cannot take the log of a negative value. That has to do with the domain, and that'll be discussed in the next lesson with graphing. But then the next rule says log base b of b equals what? Well, if we think about it, we'll think about it like this. B to what power equals b? Well, that has to be 1. So our first rule is that log base b of b always equals 1. The next rule says b to what power would give me 1? Well, the only number it could be is 0. So anytime we take the log of 1, it will always be 0. And the last 2 properties here deal with the inverse function, the fact that logs and exponentials are inverses of each other. And if we have log base b of b to some power, what happens is that power actually becomes your answer. It's like these cancel out. Same thing will happen over here. If I have b to the log base b, it's like they cancel out, and I'm left with whatever is in this place. And those are some properties that we can use to simplify our logarithms. And the last thing in this lesson is about how to use your calculator button. You've got 2 calculator buttons. One of them is a log button, and if you look, you'll see it says LOG, or possibly LOG. And then your other button, sometimes it's lowercase, sometimes it's not. And so you can actually plug these into your calculator only if they have the common logarithm, log base 10, like these do, and you'll find that the answer to number 1 should be 2 when you plug it in, and number 3, the answer should be -3. And then the natural logarithm, you have to type that in. And for these, we're going to round to 3 places. That's how we want to round those. So this has been evaluating logarithmic functions.
Made with Doodlecast Pro.